now I will present my work on the fabrication and characterization of functionalized composite endowing sand with improved water and nutrient retention capacity. The presentation will be divided into 4 sections. So for the first part, about background. Back in the summer of 2022, I was staying over at my friend's home in Tampa, Florida. And I noticed something different about the soil over there. It was kind of like sand, and after a rainfall, the water will dry quickly, just like in sand. So I'm wondering how well would the plants grow if it was not for the tropical climate and the ample rainfall in Florida. Desertification and eutrophication are some of the significant environmental issues. Desertification will lead to sandstorms, low soil productivity, as well as loss of biodiversity, while eutrophication, caused by the accumulation of fertilizers and nutrients in water bodies, can result in further increase of fertilizer consumption and disruptions in water ecosystems. As we all know, water and fertilizer, nutrient, and sand will be lost instead of being absorbed by the plants. To overcome this, it is necessary to develop a high-performance, water-saving, and nutrient-retaining technology to control the water and nutrient migration in sand, which can consequently increase the water and nutrient utilization efficiency, and therefore favor plant growth to alleviate the environmental issues addressed previously. So here comes the question. In order to improve the water and nutrient retention capacity of sand, can we fabricate a water and nutrient loss control agent that improves the ability to retain such resources in sandy environments? Also, how do we choose the key components and the optimal composition ratio? We selected some environmental friendly chemical compounds that have strong water retention capabilities. Based on the components and their functions, a network of water and nutrient loss control agent, which we'll later refer to as WNLCA, is prepared by self-assembly to form a 3D structure in the aqueous phase, which can effectively glue sand, water, and nutrient molecules together. After preparing the agents, we put samples with water and different ratios of chemical compounds into the oven, and we'll identify the sample with the highest water utilization efficiency. We'll also perform leaching experiments and identify the composition ratio with the best nutrient loss control performance. This is a video recording of one of our leaching experiments. In this experiment, we applied WNLCA of different concentrations with sand, low concentration toward the left and high concentration toward the right, and add potassium nitrate solution to imitate fertilizer and water being applied to sand. The different time it takes for water to completely leach out directly showcases the influence of our agent, and the potassium nitrate concentration in the collected solution is tested with ultraviolet spectrometer in order to calculate the nutrient loss control efficiency. Such are the results of the characterization of our material, achieved using apparatus such as SEM, FDIR, and UV-Vis. The following step is to apply our WNLCA material into pot experiment and analyze its effect based on the observation of plant growth, in our case, grass, under different conditions. So for the experiment, we created 6 distinct conditions with different compositions of control agent and fertilizer. The influence of WNLCA can be demonstrated through comparing the growth of the grasses. For the pot experiment, we recorded 13 days of plant growth using time-lapse photography technique. The different conditions are clarified at the top of the video. Each group consists of 20 seeds at the beginning, and no water is added after the first time. The 2 groups on the same column share the same conditions as parallel experiments, since we want to limit the experimental error that are present. On day 4, we observed that the plants have sprouted. Starting from day 5, all the plants have entered the rapid growth period. On day 10, we observed that certain individuals have begun to collapse. This trend became more significant on day 11, as we can see that plants without WNLCA have mostly fell. By day 13, all of the plants have collapsed. Among all groups, the rightmost group with potassium nitrate, as well as a higher concentration of WNLCA, lasted the longest. For the conclusion, by applying WNLCA, the water loss can be reduced by 31%, and the duration of grasses can expand by 15% without the presence of consistent irrigation, as indicated by the pot experiment. We repeated the pot experiment for 3 times and obtained similar results every trial. We have applied for patent with this novel approach. Thank you so much for your time.